Good afternoon. We're going to continue what we started yesterday, looking for the equation of a tangent line. And to do so, we need to find the slope of that tangent line at a given point. So yesterday we learned about method 1. And today I'm going to show you a different method that works very similarly, uses a similar difference quotient, and gets the same basic answer, just a little bit different bit of algebra. Again, both methods work. I'm going to show you both, and then you can choose how you'd like to do them. So if at the end of this you're thinking to yourself, I liked the method yesterday better, then you can continue to use method 1 on today's problems. It will not make any difference. You'll get the same answer both ways. Again, it's just an alternate method, and I wanted to make sure everyone had a chance to get some help from me, since I know yesterday a lot of you were probably struggling at home and didn't join in on the Zoom. Which again, I strongly recommend that you do. I might actually start forcing you to do so and making it mandatory every day, since so many of you are not doing your work or doing very well. So again, we've got to find a better way to get some of our stuff done. And again, some of that goes on you. It's time for you to start stepping up and asking for help. So thank you for those of you that actually did ask for help yesterday, but it wasn't enough. Definitely wasn't enough of you. All right, so again, the method at the bottom, method 2, that's what we're going to be working on today. And again, things are very similar. The main difference is that what we're looking at is in the denominator, the way it's been written. Yesterday we had x minus a, and again we were talking about as x approached a, meaning that these two numbers are getting closer and closer together, making their distance apart 0. And today the h has kind of already been calculated, and we're looking at what happens when that number goes towards 0. All right, so hopefully this makes a little bit of sense. So let's try an example. Well, this should look somewhat similar. We did this example yesterday as well. I'm just looking for it at a different point. If you remember yesterday's video, we had looked at this graph of this particular parabola that goes something like this. Yesterday we were finding the equation of the tangent line here. So we had, whoa, that totally missed the dot. So we had a positive slope. And today, if we're looking at what's happening at the graph at 5, we'll be over here. So I'll be expecting the tangent line to have a negative slope. All right, so let's go ahead and try to figure this out based on this new formula. All right, so start us off. We have to find, again, we're looking for the limit as x, oops, not x, but h, sorry, as h approaches 0. And then the formula was f of a plus h, and then minus f of a all over h. So everything's all about figuring out just where to plug things in. So the first part, the f of a plus h, this is the mess. This is where we're going to have to do a little bit of work. So let's kind of do that kind of off to the side here a little bit. So let's look at what is f of a plus h. That means take the a number or the x number out of the equation. I don't know why we are switching from x's to a's, but that's the way the formula works. X's and A's and H's and all this stuff, that's definitely can be a confusing piece. All right, so if we go back to the beginning, remember that this is A and this is f of A. That might help a little bit. So we're going to do f of A plus h. Well, I don't know what h is. So that means I have really got to do the original function, negative 16, take the x out of the equation, and I'm replacing it with A plus h. Well, I know A is 5, but I don't know h. And then plus 96. And again, take the x out, replace it with a plus h. Well, I know the a is 5, but I don't know the h. So again, there's a little bit of algebra going to happen here. So first off, I'll have to actually do FOIL with a 5 plus h, which would get me 25 plus 10h plus h squared. It's backwards. And then back in this back one over here, I've also got some distributive property. And that would give me 480 plus 96h. And I've still got some distributive property up here in the front as well. And if I do that, that's going to get me negative 400, and then minus 160h, and then minus 16h squared. And then I've still got plus 480 plus 96h. All right, let's combine our like terms and get this in standard form. Largest exponent squared. And next we got our exponent h's, and there's two of them, negative 160 and 96. And that together will make negative 64h. And then my constants, negative 440 480 would make 80. So that's this part right here. That's all I did, right? But that's where the majority of the work is in this problem. But that's all I just found was that little piece. So now let's kind of fill some things in. Let's kind of go back. Now that I know that big awful piece there, negative 16h squared minus 64h plus 80. And then I'm going to minus f of a. Well, I know what f of a is. F of a was back here. It's 80. I don't have to do any work for that. So minus 80. And then the denominator is h. And I don't know what h is. I want it to be 0, but right now I don't know anything for it. So in the numerator, those 80s cancel out. And I can't have the denominator head to 0, so I've got to find a way to cancel out that h from the denominator. So if you look in the numerator, the two terms that are left both have h's, so let's factor out that common h. Now we can cancel h from denominator. Now we can finally plug h equals 0 into what we have left. So that's our next stage. We now want to know the limit as h approaches 0. And again, here's what we got left. Negative 16h minus 64, but make h a 0. So that'd be negative 16 times 0 minus 64. And that would make a 0, and there's your slope. Whew. I'm not done yet. I'm just letting you know that that's your slope. Now you can put it back into your point slope form. Back at the beginning here, there's our point, 580. So y minus the y1 coordinate equals m. We just found it. And then x minus the x1 coordinate. Multiply out my distributive property. Always do parentheses first. That's negative 64x. Then negative 64 times negative 5 is positive 320. And then add 80 on both sides. Y equals negative 64x plus 400. There's your equation of your tangent line. Now, if in your mind this was more work and more difficult work than yesterday's, then you don't have to do it this way. You may continue to do it the way I showed you yesterday. Now, if you were one of those people that didn't pay 2 craps of attention yesterday, and you didn't able to figure this out, you didn't get me on the Zoom, and you just kind of gave up, then maybe you need to take today, while you're here with me, sorry, Amelia and Anna, you don't ever come to see me, but the rest of you are, and you should be asking questions and asking to help you with this today. All right? We're going to be working on some similar stuff later in the week. This won't go away quick, so please let me know if you need any help. All right, good luck.